All right, section 2, we're going to look into our probability rules and start building our basics in terms of what we're going to do when we are asked to find the probability of certain things happening. So, number one, we're talking about a probability model or a sample space. Okay, what this is, it's somehow you're showing all your possible outcomes. Okay, so flipping a coin. We use capital S to represent our sample space. Outcomes, heads, tails. Okay. Roll a die. Sample space, 1, 2, 3, 4, 5, 6. Okay. So just list them out. A lot of times if I have a sample space, it's much easier for me to get my probability than try and use some of our rules that we're going to have down the line. We could also use a probability model. It could be a table. Okay. And we'll get into those more when we're going to talk about outcomes and probabilities of those outcomes. Okay, we're also going to see two-way tables. We're going to compare a couple different variables. Okay, event. Okay, this is what's going to be our success. Okay, event is what I'm looking for the probability of. So, the event of flipping a coin and it coming up heads. The event rolling a die and it's a 3. Okay, the event rolling a die is odd. Okay, that's what we're going to talk about, and it's not a big deal, but it's one of the things that it'll come up from time to time. And we need to know what it is. So here's our basic probability rules. Number one, probability is always going to be between 0 and 1 inclusive. And so a lot of times what they'll do is they'll write it this way: probability of event A. So again, more often than not, you're not going to say event A. It's going to be probability it's tails, probability it's whatnot. Okay, greater than or equal to 0, less than or equal to 1. Okay. Obviously, if it's 0, we probably understand already that it never happens. Okay. 1 is that it always happens. Okay. Second one, probability of our sample space again. Remember, that's what S is. My sample space is equal to 1. What it's basically saying is all my outcomes, if I add up their probabilities, will be 1. Okay, that's going to come into play a lot when we look at the table here to make sure it's a legitimate probability distribution. 3 is just kind of your definition of probability. Probability that event A happens. Okay, it's a number of successes to the number of possible outcomes. Okay, sometimes you'll see it written as success to success plus failures. Okay, do not mix this up with odds. We do not deal with odds in statistics very often. Okay, odds of success to failure. Okay, we deal with probabilities. Complement. Okay. Complement is the idea of not. Okay, so when my event A would be flipping a coin and it coming up heads. Okay. Its complement would be not heads. Okay, yeah, I know it's tails, but we want to talk about is not more often, not heads. Okay, so rolling the die. Event A is rolling a 3. Okay, the complement not a 3. Okay, I don't care if it's a 1, 2, 4, 5, or 6, but I do care that it's not a 3. Now, notation-wise, what we'll do is we'll use A. Kind of looks like A to the C power. It's a superscript. Okay, so the probability of A complement. Okay, since we're only talking about 2 outcomes, okay, and we know all the probabilities have to add up to 1, so the probability it occurs plus the probability it doesn't occur equals 1. And so algebraically, what happens if I subtract the probability that it does occur away from both sides, there's my definition. Okay. We're going to use this a lot when you see a term like at least 1. Okay, because the opposite of at least 1 is none. Okay, so that's going to come into play. Your general addition rule. Okay. This is going to be the OR piece. You got to tie addition with OR. So what it says is the probability that event A or event B happens. Okay. Anytime you see that OR, right away you got to think addition. It's those 2 probabilities individually added together. If they're mutually exclusive or another term that means the same thing, disjoint. Okay? What that means is that they can't happen at the same time. Okay? Male and female. They can't happen at the same time. 10th grader, 12th grader. Can't happen at the same time. But if I talked about males and seniors, okay, that's not mutually exclusive, because you have some males that are also seniors. Okay? And so what we'll have is we'll get our addition rule. In fact, I should cross this off because it's not really a general addition rule yet. The general addition rule will take care of everything. Okay? All right. So, talked about earlier, here's another way we can look at our distribution, a two-way table. Okay, I'm comparing two things on each individual. One, their gender. Okay? So either they're male or they're female. Okay? And the second thing is do they have pierced ears or not? Okay. One of the things, again, two-way tables, talked about them earlier. Always fill in your margins. Okay. So I'm going to fill in this margin. Okay. And make sure that when I get my totals that they add up. Okay. So what do I got here? 90, 88. Okay, that's going to be the first thing. And another way we can show this information is in terms of what we call a Venn diagram. Okay, so with the Venn diagram, we may have, if we focus on the event that someone's a male, okay, and if they have pierced ears. Okay, each circle represents males on the left circle, pierced ears on the right circle. So in that circle, here, every male has to fall into there. Okay? Now, since there's an overlap, this is where they both are. This is where we have males and they have pierced ears. Okay? Really nice tie-in with these is that there's the ones that have pierced ears, okay, and are male. They're going to fall into this chunk right here. Okay, so those 19 people are going to go here. Okay. Now, if we go into my next group, these 71, they're males, but they don't have pierced ears. So that's going to be this chunk. These people are males, but as soon as they cross that line there, that means they had pierced ears. So this group doesn't have the pierced ears. So there's my 71. Now, where you really need to be careful is sometimes they'll do this. They won't give you that. They would give you the total of 90 males. And what happens is a lot of times people come in here and say, oh, there's 90 here. But then if you look at this whole circle now, there'd be 109 people. Okay? So what we have to do is, hey, there's 90 males, but I've already put 19 of them in there. Okay? So we got to be careful with that. Okay? Continuing on. Now, when I look at this group right here, these are people that have pierced ears. Okay? But I've already put the males in there. So that's these 84. Okay? Yeah, I know it's ladies with pierced ears, but okay, we want to talk about that not situation again. So on the outside are people that are not male, okay, because all the males are inside that green and yellow circle, and people that don't have pierced ears. Okay, so that's your leftover 4. Okay. Venn diagrams can be helpful, especially when we're comparing two events. Okay, and when we look at them, we talk about things like the intersection. Okay, that's where they overlap, and sometimes you'll see that written as A and B. Other times you'll see it written as A, and this little N-looking symbol means intersection. Okay, union, that's your or situation. Success if you're A or B. Success even if you're in the middle of both of them. Okay, so that's your A or B. In a way, we write that sometimes with this U, A union B. And then here's your complement down here. Anything that's not in A. All right.